Stoichiometry, a section of chemistry that involves using relationships between reactants and products in a chemical reaction to determine desired quantitative data. First, we are going to preheat our oven to 350 degrees Fahrenheit, as said in the back of the box. It's important that you put cooking spray or cooking oil on your pan so that the brownies do not stick to it. If our recipe was written as a chemical equation, this is what it would look like. Alright guys, let's get to baking. You need to make sure you mix these ingredients well. If your batter does not look like this, then you have incorrect proportions and need to restart. After you're done evenly distributing the batter on the tray, you're going to want to put it in the oven to bake. As you're done setting in the brownies, you're going to need to put on your timer, but the time does vary on the size of the pan you use. In this case, ours was 28 minutes. Changing the proportions. Now say if we wanted to double the recipe, that would mean that we have to double the reactants, which means we would need 2 packets of brownie mix, we need 4 eggs, and we need 1 1/3 cup of oil and 1/2 cup of water. And then all you would have to do is just double the grams for each reactant. Limiting reagent. It is simply the substance in a chemical reaction that runs out first. Let's say I had all the ingredients, well, most of the ingredients, to make double the amount. Except for the eggs, I only had 2 eggs as from the beginning. This would be considered the limiting reagent. Now as you can see, the brownies are starting to rise, and this is caused by baking soda inside the brownies. Baking soda produces carbon dioxide as well as water and sodium. The following equation that is going to appear on the next screen is baking soda mixed with water and sodium. So now we have here is the chemical equation, which is NaHCO3 plus H, and on the other side we have Na plus H2O plus CO2. And once again, this is what makes the brownies rise up as they are baking in the oven. So now that we have this equation, we can now find the moles, and the moles are the leading coefficients in front of each chemical. So notice this one is for all of them because they all have one leading coefficient. And the molar mass is all of the chemicals combined together, and we put it in grams, and the underlined grams are what we are going to be using in the next equation. It's going to be on the next slide. Using the conversion factor from the recent slide, we are able to calculate the 521 grams of baking soda, which yields to 272 grams of carbon dioxide. Well, looks like there we have it. The brownies are done, and you have now learned how to master stoichiometry. I hope this really helped you guys, and thank you guys for watching. Now we can enjoy them. Bye!